Hello friends, welcome to our channel. In previous video, we already discussed about the sets, types of the sets and some definitions. In today's video, we will discuss about cardinality of set, inclusion and exclusion property of sets with examples. Cardinality of sets. What do you mean by cardinality of sets? Basically, cardinality of sets refers the size of the set. In the other words, we can say that the number of elements in the set. The cardinality of set A is generally denoted by modulus of A or n of A. Modulus of A, that means the size of the set A. N of A, number of elements in the set A. So cardinality of the set is the number of elements in the set. Cardinality for both finite and infinite set. So first we will discuss the cardinality of finite set. Cardinality of finite set. Consider a set A if A has only a finite number of elements, then cardinality of the set A is equal to number of elements. Suppose A is the set of vowels in English alphabet. That is, A is equal to A, E, I, O, U. In this set, there are 5 elements. So cardinality of A, that means modulus of A, is equal to n of A is equal to 5. Now the cardinality of infinite set. Let A be an infinite set then either A may be countable or A may be uncountable set. Now first we will discuss the definition of countable and incountable set. First, what is the countable set? A set is said to be countable if it is finite set or the set can be put one to one correspondence with the set of natural numbers. We can write A as A1, A2, A3, A4 and so on. Set is infinite set, but we have to count it as A1, A2, A3, A4 up to so on. So it is a 1-1 correspondence between the set A to the natural number. Therefore set A is countable. Second, uncountable set. A set is said to be uncountable if it is not countable. Set of real number is uncountable set. Next, the inclusion-exclusion principle of set. What is inclusion and exclusion property? Inclusion and exclusion principle. Let capital A and capital B are any two sets they must be finite. That is, capital A and capital B are any two finite sets. Then A union B, its modulus. That means the cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B, or n of A union B is equal to n of A plus n of B minus n of A intersection B. That means the number of elements in A union B is always equal to the sum of number of elements of A and number of elements of B minus the number of elements in A and B both. When we add modulus of A and modulus of B, we are counting the elements in A intersection B twice, thus by subtracting A intersection B from modulus of A plus modulus of B, we obtain the numbers of elements in A union B. We see graphically that suppose A and B are any two sets, then this area lining part is A intersection B. So this part is counted in A as well as counted in B. So A union B is equal to A modulus, that means the number of elements in A, plus modulus of B, that means number of elements in B. So this part A intersection B repeated 2 times. So we have to subtract 1 time. That means modulus of A intersection B. If A, B, C are any 3 sets, then cardinality of A union B union C is equal to cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B minus cardinality of B intersection C minus cardinality of A intersection C plus cardinality of A intersection B intersection C. Graphically we see that A is any set, B is another set, and C is the third set. Then A intersection B intersection C is this part. The studied part is A intersection B intersection C. We add A, cardinality of A plus cardinality of B and cardinality of C, and subtract A intersection B, B intersection C and A intersection C. Then this area is subtracted 1 more times. So we add A intersection B intersection C. Generally for n finite sets, let A1, A2, A3 up to AN. We can write the cardinality of union I varies from 1 to n AI is equal to summation I varies from 1 to n AI, that means the cardinality of each set, A1 plus A2 plus A3 and so on, minus summation I is less than j AI intersection AJ, its modulus, plus summation I is less than j less than k AI intersection AJ intersection AK, and so on, minus 1 raised to power n minus 1 A1 intersection A2 intersection AN. This generalization to an arbitrary number of finite sets is called the inclusion-exclusion principle of sets. Now we can solve a numerical based on this formula. In a group of people, 30 on a dog and 25 on a cat. Find the number of people who on dog and cat both. Solution. Let D and C are the sets of owners, dog and cat respectively. Then D modulus, that means the number of owners on dog is 30. Modulus of C, owners of cat 25, and D union C is less than equal to 50 because there are maximum 50 people. So D union C is less than 50. We know by inclusion-exclusion property, A union B modulus is equal to A modulus plus B modulus minus A intersection B modulus. So using this property, modulus of D union C is equal to modulus of D plus modulus of C minus modulus of D intersection C. This implies modulus of D union C is equal to modulus of D plus modulus of C minus modulus of D intersection C. This implies 50 is greater than equal to modulus of D plus modulus of C minus modulus of D intersection C. This implies modulus of D intersection C is greater than modulus of D plus modulus of C minus 50. This implies modulus of D intersection C is greater than equal to 30 plus 25 minus 50. This implies modulus of D intersection C is greater than equal to 5. So at least 5 people must own both dog and cat. It is sufficient for today. In next video, we will discuss some more examples and definitions related to sets. So keep in touch, watch our videos and subscribe our channel for more videos. Thanks to all. Have a nice day. Bye bye.